Hello everyone, I am Dr. Munish Bharadwaj from School of Engineering and Technology of IGNOU. So in our last lecture, we discussed about workability and what are different methods of measurement of workability. Now we will move to the other methods of measurement of workability. So in last lecture you saw that we discussed slump test and compaction factor test. So now we will move to the other test, flow test and VB consistometer test. After discussing these two tests, I will discuss with you the workability for different conditions. So let us move to the flow test. Flow test is more suitable for the flowing concrete or the concrete with superplasticizers. It means the concrete which is having high water quantity or it is having superplasticizers, because use of superplasticizers in concrete makes it more workable. It can easily flow. For such concrete, we will use the flow test for measurement of its workability. In addition to the measuring workability, this method also helps in observation of consistency, cohesiveness and segregation characteristics of concrete mix. So it means that in addition to measuring the workability by this test, it is possible to observe the three properties of the concrete mix. What are these three properties? Consistency of the concrete mix, cohesiveness of the concrete mix and segregation characteristics, if there is any possibility of segregation of the concrete mix. These things also you can observe with the help of this test. Now here you see the flow test apparatus. In this, on the upper part, you see here the mold for the flow test, and as you see here, the top diameter of this mold is 17 centimeter or 170 mm. If you say in mm, it will be 170 mm. Bottom diameter is 25 centimeter or 250 mm, and it's a metallic mold made of metal. Below this you see the apparatus, flow test apparatus, in which at the top is table, basically the brass table. Diameter of this table is 76.2 centimeter or 762 mm. And below this there is a cam which helps in raising and falling of this table, and this cam is moved with the help of the handle that you see on its left. So this is the apparatus. How we will use it, that we will see here. In actual picture, if you look at, so this looks like this, the whole arrangement. You see here the mold kept on the table, then below this that arrangement for supporting this table, and cam and the handle by which you will be rotating it for moving the table up and down. There is another picture of another type of this apparatus. Rest things are same, and the mold, the table, the rotating handle, the handle for rotation and cam. So these are the two different type of pictures having the two different type of apparatus, but the basics of these apparatus are same. Working operations are same. Only the physical look are different. So as you saw in the picture, the shape of the metallic mold is similar to the mold that we use in the slump test. The only difference is the dimensions. If you remember, in case of slump test, what were the dimensions? The top diameter was 100 mm, bottom diameter was 200 mm, and the height of the mold was 300 mm. Whereas here the dimensions are top diameter 170 mm, bottom diameter 250 mm or 25 centimeter, and height here is 12 centimeter or 120 mm. So this is the difference. Both the molds are frustum of cone that we used in slump test as well as in flow test. So shape is similar, only the dimensions are changing. Metallic mold is placed in the center of the flow test. So this is the first step, that you will take the mold and place this mold in the center of the flow table. This metallic mold will be firmly held in place and concrete will be filled in 2 layers in it, each approximately 1/2 of the volume of the mold. So that way we will be filling the concrete in the mold in 2 layers. Each layer is rodded with 25 strokes. Each layer is rodded with 25 strokes of a metallic tamping rod, which is 16 mm in diameter and 610 mm long. So using this tamping rod, we will be compacting this concrete or tamping the concrete by giving the 25 strokes of the metallic tamping rod. Now the strokes shall be distributed in a uniform manner over the entire cross section of the mold and shall penetrate into the underlying layer. Means when we are giving these strokes, then these strokes has to be given uniformly throughout the cross section of the mold and in such a way that our tamping rod is penetrating into the underlying layer. It is going to the layer below the top layer. After the top layer has been rodded, strike off the surface of the concrete with a trowel so that the mold is exactly filled, because we have to remove the extra concrete which is coming out of the mold. So use the trowel to strike off the extra concrete on the mold. Now the excess concrete which has overflowed the mold is removed and the area of the table outside the mold is cleaned. We have to clean the area which is outside the mold because our table is much bigger than the size of the mold. So some concrete may be falling on the table beyond the mold also. So we have to clean the table clearly. Now the mold is removed from the concrete by steady upward pull. So you will be removing now the metallic mold from the concrete, lifting it slowly, lifting it upward slowly. The table then is raised and dropped 12.5 mm. For what height? 12.5 mm it will be raised and dropped. How? We will be using the handle. We will be using the handle, and this handle, it will rotate, and this cam in this apparatus will do the work. What that work? That it will raise the table and then it will drop it. Raise and drop. So such type of action will be there, and this height of fall is 12.5 mm. And that we will do for 15 times in about 15 seconds. Means one time in 1 second. For one raising and falling, it will take 1 second. So this is the rate of that raising and dropping that way. So what it will do basically? By doing so, what will happen that when you remove the metallic cone from the concrete, initially the concrete was in the form of the conical shape. Now when we are raising and dropping the table, due to the vibrations, the concrete will now flow, and it will change its shape from that conical shape, to the shape of it will spread on the table. It will spread on the table, and that conical shape will go. So now what will happen, that concrete will spread on the table and almost in a circular form. So the diameter of the spread concrete is the average 6 symmetrically distributed caliper measurement read to the nearest 5 mm. Means you have to measure the diameter of the spread of the concrete, and that you have to measure in 6 symmetrically distributed directions. In 6 directions we have to take the measurement that what is the diameter of the spread concrete. Means the concrete that has spread on the table, we have to measure the diameter, and that too in the 6 directions, and that measurement has to be taken exactly nearest to the 5 mm correctly. Means the diameter has to be measured with an accuracy of 5 mm measurement, and we will be taking the average of these 6 readings as the diameter of the spread of the concrete. Now flow of the concrete is recorded as percentage increase in diameter of the spread concrete over the base diameter of the molded concrete. And how it is calculated? This flow in percentage will be calculated by using the formula that spread diameter in centimeter minus 25 upon 25 into 100. So where from this 25 minus 25 and in denominator the 25 is coming? If you remember, the bottom diameter of our metallic mold was 25 centimeter. So initially when we are removing the metallic mold from the concrete, the bottom diameter of the frustum of cone of the concrete was 25 centimeter. And when we are raising and dropping the table, then concrete is spreading on the table. Then we are measuring here that what is the percentage increase in the spread of the concrete. So initially we started with 25 centimeter diameter, and now after spreading, the spread diameter has increased. So we are calculating the percentage increase in the spread diameter of the concrete. So that way this 25 minus 25 and the 25 term is coming in the denominator. So this way we can calculate the percentage flow. So this will be recorded as the workability for concrete measured by the flow test. Now our next method for measurement of workability is VB consistometer method or VB consistometer test. So consistency of concrete is determined by this method. Means this method focuses on measurement of consistency of concrete. What we do in this method, it involves determination of the time required for transforming a concrete specimen in the shape of a conical frustum into a cylinder by vibration. Means what we'll be doing here, that initially our concrete will be in the shape of a conical frustum, and we will be giving vibrations to this conical frustum, and it will transform into a cylindrical shape. So the time taken in this process will be recorded for measurement of the consistency of the concrete. The VB consistometer consists of a vibrated table resting upon elastic supports. Means there is a table which is resting on the elastic supports. There is a metallic pot which is in the shape of cylinder, and we use here also the slump cone that we used in slump test. So same slump cone we will be using here, which is of the dimensions of height 30 centimeter, bottom diameter 20 centimeter, top diameter 10 centimeter. So this slump cone we will be using here in this VB consistometer test also. Here you see the VB consistometer apparatus. So as I told you that there is a slump cone. So here you see A is a slump cone which is capped in the metallic pot or in the shape of which is in the shape of cylinder. B is the metallic pot in the shape of a cylinder, and this whole arrangement means that cylinder and the cone, now you see here, is resting on a vibrating table, and this vibrating table is supported on elastic supports. And next to it you see here the fuel rod, and on this rod there is a funnel which helps in pouring the concrete into the slump cone, and on another side you see a glass disc which helps us in measurement of the slump, because using this apparatus you can measure the slump of the concrete as well as the VB consistometer time also, or you can say VB time or VB degree. So both the things are measured with the help of this apparatus. And for measurement of the slump, you see above the glass disc there is a graduated rod. So by moving this graduated rod we can measure the slump of the concrete. So this is the description of this VB consistometer apparatus. The vibrator table that you saw is having dimensions of length 380 mm and width 260 mm. So this is the size of the vibrator table. This table, as you saw in the picture, is supported on shock absorbers at a height of about 305 mm above the floor level. The table is equipped with an electrically operated vibrometer mounted under it. So this electrically operated vibrometer gives the vibrations to the table, and it is placed under the table. So as I told you, here you see the slump cone and the cylindrical pot, metallic cylindrical pot, and the vibrating table, and you see the funnel on left and right. You see the glass disc and the graduated rod. So that way this apparatus will be used for VB consistometer test. So as I told you that you can measure the slump with this test. So slump test is performed in the sheet metal cylindrical pot of the consistometer. How? The glass disc attached to the fuel arm is moved and placed just on the top of the slump cone in the pot. The position of the concrete cone is noted, means here we will be noting the reading on the graduated rod by adjusting the glass disc attached to the swivel arm. So means initial reading we have noted on the graduated arm. Now the cone will be lifted up and the slump is noted on the graduated rod by lowering the glass disc on the top of the concrete cone. So here the glass disc will touch the top of the concrete cone and we will take the reading on the graduated rod. So that way we can measure the slump. Now what we will do after measuring this slump? The electrical vibrator is then switched on and the concrete is allowed to spread out in the cylindrical pot. So what will happen that once we are starting the electrical vibrator, so the concrete mix will vibrate and now it will spread in the cylindrical pot and it will take the shape of a cylinder. As you know that the liquids take the shape of the pot in which they are capped. So here also our concrete is in plastic state, so on vibration it will take the shape of the cylindrical pot in which it is capped. Initially, after removing of the slump cone, it was in the shape of a frustum of cone. Now due to vibration it will spread and finally it will take the shape of the cylindrical pot. The vibration is continued till such a time as the conical shape of the concrete disappears and the concrete assumes a cylindrical shape. So we have to vibrate till this stage, and the time required for the shape of concrete to change from slump cone shape to cylindrical shape in seconds is known as VB degree. This method is very suitable for very dry concrete whose slump value cannot be measured by slump test. So this is the importance of this test, that this test is more suitable for the dry concrete, very dry concrete, for which slump value cannot be measured by the slump test, because there in slump test we will not be able to get the slump of such concrete because it is in very dry state. This test is not suitable for highly workable mix or wet mix, generally if the slump is more than 75 mm or so, because for such mix the remolding is so quick that time cannot be measured, because here we are measuring the time for which the shape is changing. The shape, it is there is a transformation of the shape, means from conical shape to the cylindrical shape. This transformation is occurring, so we are measuring the time for such transformation. But if our concrete mix is highly wet or highly workable, so the time will be so small that we cannot measure it actually. So that way this test is not suitable for a concrete which is highly workable or highly wet. So this is the limitation of this test. Now let us see some suggested values of workability for different placing conditions, and these workability values are here given for the maximum size of aggregate when it is 20 to 40 mm. So if you are using the aggregate of size between 20 to 40 mm, which is the maximum size of aggregate for such concrete, these are the suggested values of workability for different placing conditions. Let us see. Here you see different columns. First column give you the degree of workability. Second column give you the slump in mm. That for such degree of workability, what is the approximate value of the slump. The third column gives here the compaction factor value, means which is obtained from the compaction factor test. The fourth column gives here the VB time or the VB degree in seconds. As you know that VB time is measured in second. And last column gives the placing conditions, that in which conditions this concrete can be used. So these are the conditions. So here let us take the first case, very low, means when the degree of workability of the concrete mix is very low. So for such concrete mix, generally the slump is between 0 to 25 mm and the compaction factor is between 0.75 to 0.80. And for such mix, the VB time is 20 to 10 seconds. And such concrete is used for concreting of shallow sections with vibrations. Means when we are using vibrations and the concrete is to be used in the shallow sections, or pavements using pavers or power operated machines. If you are constructing pavements using the pavers or the power operated machine. So in such conditions, this concrete mix is used. Next is our low degree of workability, and slump value for such concrete mix is 25 to 50 mm. Compaction factor for such mix is 0.8 to 0.85, and VB time for such mix is generally 10 to 5 seconds. And what are the placing conditions? Means where this concrete may be used. Such concrete is used for mass concreting without vibrations. Also, you can use this concrete for lightly reinforced sections with vibrations, such as in slab, beam, walls, columns and floors. This concrete can also be used for hand compacted pavements. Also, you can use this concrete for canal lining and also for strip footing. So these are the placing conditions for use of the concrete mix which is having degree of workability as low, means low workability. Next is our medium workability. For medium workability, slump value is generally 50 to 100 mm. Compaction factor is 0.85 to 0.92. VB time is 5 seconds to 2 seconds for such mix. And this concrete mix you can use for normal reinforced concrete which is manually compacted. You can also use this concrete for heavily reinforced concrete sections with vibrations in slabs, beam, walls, columns, slip formwork, and also you can use this concrete when the concrete is to be pumped, means for pumped concrete. So for such conditions, you can use the medium workability concrete mix. Next is high workability concrete mix. High workability concrete mix will show the slump as 100 to 150 mm and compaction factor between 0.92 to 0.96. VB time for such concrete is difficult to measure because it is highly workable, and as I told you in VB consistometer method that this method or the test is not suitable for highly workable concrete mix. So here this is not noted. And let us see what are the placing conditions in which we can use such type of concrete mix. You can use such type of concrete mix in sections with congested reinforcement which is not normally suitable for vibration. Means if the reinforcement is very congested, so it is difficult to give the vibrations also. So for such conditions, we are using the high workable concrete or concrete having the high workability. You can use this concrete in trench fills and also for casting the in situ piles. Means in situ piling work, you can use such type of concrete. So these are the different placing conditions for the different type of concrete mix. So here you saw that we discussed the two tests. First, for measurement of workability of the concrete mix. First was our flow test and second was VB consistometer test. So these two tests we discussed here for measurement of workability of the concrete. And after that I discussed the different placing conditions for different type of mixes, means concrete mixes having different workability. For that we discussed that where we can use such type of concrete mix. So this overall discussion was about the workability. So I hope you must have understood the workability, its measurement and the placing conditions for concrete mix of different workability clearly. So thank you for watching.